Okay, let's dive into this explainer. It's wild. Have you ever wondered why the absolute smartest AI coding agents we have today still, well, kind of have the memory of a goldfish? I mean, every time you start a new conversation, it's like a complete blank slate. They forget everything they just learned. Well, today we're exploring a seriously fascinating research paper from July 2026 by the V-Engine research team. They are literally changing the game by giving coding agents a permanent, evolving memory system. They call it the CatGame Memory and Dream system, and honestly, it's basically a cure for AI amnesia. So, to tackle this complex architecture without getting totally overwhelmed, we're going to follow a clear roadmap today. We'll start with the AI amnesia problem, then look at their bio-inspired solution. After that, we'll break down the three layers. Layer 1 is the memory skill, Layer 2 is the dream skill, and Layer 3 is the infinite daemon. Finally, we'll wrap up with the dream knowledge graph. All right, let's just jump right in. Part 1, the AI amnesia problem. Let's start by looking at the core issue that's really plaguing modern AI agents right now. I want you to picture a literal Groundhog Day scenario. Just imagine the sheer frustration of doing a highly complex job, like, say, software engineering, but waking up with absolutely zero memory of your past mistakes. Having to reread the exact same code, rederive the exact same architectural insights, and retrace the exact same bugs every single time you start a new work session. That is exactly what modern LLM-based coding agents are experiencing right now. The researchers actually call this session boundary forgetting. Now, the big takeaway here, the so what, is the massive waste of compute time. Because the agent starts completely from scratch, armed only with what you manually give it, we get this compounding ignorance. The AI entirely loses its causal context from session to session. So instead of fixing the root causes upstream, it's forced to just sort of slap on these messy, symptom-level band-aids. Section 2, a bio-inspired solution. To fix this amnesia, the researchers didn't just write a basic database script to save chat logs. No, they actually looked to biology. Specifically, they looked at human hippocampal memory consolidation. Think about it. As humans, during slow-wave sleep, our brains literally replay our episodic daily memories. We transfer them to the neocortex to build generalized semantic knowledge about how the world works. And the CatGame Dream system mimics this exact complementary learning. The AI experiences fast, episodic learning during its waking work session, and then, this is the cool part, it consolidates that into permanent semantic storage during its sleep phase. So this bio-inspiration translates directly into a unified three-layer cognitive consolidation pipeline. You've got the memory skill, which represents the waking state, then the dream skill, representing semantic sleep consolidation, and finally, the infinite daemon, which acts as this sort of subconscious heartbeat, chaining the whole thing together. Let's break these down one by one, starting with the first layer. Section 3, Layer 1, the memory skill. Think of this as the AI's active, working memory while it's awake and completing a task for you. During a single work session, the memory skill cycles through 4 precise phases. First, it audits existing memories to check for anything stale. Second, it collects new events by scanning its logs, code plans, and session journals. Third, it consolidates them by creating or updating memory records. And finally, it persists them by reporting the actual memory counts. Essentially, this creates a real-time episodic trace of exactly what the agent is doing and learning right in the moment. But here's the catch. The system doesn't just hoover up and save everything equally. It actually uses a formal importance scoring function. Mathematical weights are assigned to different types of knowledge. For example, big architectural decisions, those carry a perfect 1.0 weight. Root cause bug diagnoses get a 0.9. But simple, everyday observations, those only get a 0.5. By mathematically weighting these categories, the system basically guarantees that the critical, structural decisions are prioritized. It completely avoids that endless buildup of digital clutter. Which brings us to what happens when the workday ends. Section 4, Layer 2, the dream skill. Once the AI effectively goes to sleep, this incredible 5-phase cycle kicks off. It collects the recent session history, extracts the semantic patterns, integrates a self-model, reports the ranked insights, and then persists everything to a permanent file. And here's a really amazing detail. During this cycle, the system applies an approximation of the famous Ebbinghaus exponential forgetting curve. It evaluates the recency decay of its memories. If a memory's importance score drops below a certain threshold, and it happens to be older than 90 days, it just gets archived. So it discards the useless episodic data and only consolidates the truly valuable traces into permanent knowledge. It's literally forgetting on purpose to get smarter. Also, during the integration phase of the dream, the AI constructs a 5W self-model. That's the who, what, where, when, and how. Who is the agent? What action was taken? Where were files altered? When did it happen? And how was it done? Now, the crucial thing to take away from this is that the paper actually includes a mathematically proven minimality theorem for these exact dimensions, meaning it mathematically proves that these 5 independent variables completely and perfectly cover the description of an agent's actions. It guarantees the AI fundamentally understands its own actions in context before moving on. So, we've got the waking memory and the sleeping dream. Now for section 5. Layer 3, the infinite daemon. This is the layer tying it all together. Think of the infinite daemon as the subconscious heartbeat of the AI. It orchestrates operations continuously across sessions, operating as a super strict 8-state machine. It dispatches workflows, processes batches, and, this is huge, it verifies the agent's assertions against actual code builds and test failures. So if the AI remembers something that is contradicted by a failing test, it immediately gets flagged as incorrect memory pollution. Actually, to keep things in check, this state machine is bound by a strict 1800-second cooldown timer between batches. That ensures fair rate limiting and persistent operation without just burning through endless compute cycles. All right, now for arguably the most exciting part, section 6, the dream knowledge graph. Let's see what this actually looks like in practice. Because this persistent memory, it isn't just stored in some flat and boring text file. No way. The system builds an intricate, agent-introspective 3D knowledge graph. Every single node is a memory or insight, and the arrows connecting them are semantic relation edges. We're talking relationships like causes, reinforces, resolves, or evolves _into. The AI is quite literally mapping out its own reasoning process over time. It's connecting a bug fix from yesterday directly to an architectural decision made 3 weeks ago. It's like a giant evolving puzzle of its own mind. And it scales beautifully too. In the paper's evaluation, accumulated over just 25 dream sessions, the AI's consolidated knowledge graph reached 863 nodes and 1,250 edges. That is an impressive edge-to-node density ratio of 1.448. To put that into perspective, the researchers proved through formal graph theory, using something called the handshaking lemma, that this density means the AI is highly successful at deduplicating memories and densely connecting concepts, rather than just hoarding fragmented lists of data. Let me give you a perfect real-world example from the graph. During a session on June 27, 2026, the agent discovered a nasty, complex bug involving circular dependencies in computed flags. It ranked this insight with a massive 0.95 importance score under the root cause category. This absolutely hits the nail on the head when it comes to curing AI amnesia. Because the AI extracted the semantic rule, verified it, and linked it into its dream graph, it will literally never waste expensive compute time trying to figure out this exact problem ever again. So if an AI can continuously learn, mathematically prioritize its memories, and physically dream to build an evolving graph of its own existence, are we looking at the birth of a truly persistent synthetic collaborator? It's a wildly fascinating, almost cyberpunk reality to consider. We are rapidly moving from single-use chat interfaces to AI agents that actually accrue wisdom over time. I really hope this explainer has helped you grasp exactly how the CatGame system bridges the gap between temporary scripts and permanent machine cognition. When you look at how closely it mirrors human memory, you kind of have to wonder, what exactly will these systems dream up next?